Alright, so I got a suggestion to cover custom triggers for enhanced input. So I'm going to assume you already know the basics of enhanced input, and if not, I'll put a card in the corner. But let's get started here. So I already have my character, I have the mapping context, so I have click to move, and I'll keep it simple with a jump trigger. So right now I can jump when not moving, but I'm going to make it so you can only jump when you've hit a certain velocity. So if you've got a running start kind of thing. So create a blueprint and search for trigger. We're only doing the standard trigger, not the timed one yet. So open that up. And in functions, we have only two options. All you can do is really update state. So we'll override update state. You can delete that. Okay, so we have player input, modified value, and delta time. What we need is player input. We can drag out get outer A player controller. Get controlled pawn. Get velocity. And your demo character, I'm just checking the max walk speed. So if I want it to be like if you're near the max running speed, then you can jump. Hold on, then we need to do vector length. So if that is greater than, so I'll give you a buffer. Let's do 550. And then we can just drag out the output pin here. Use a select node. Plug into the condition here. True. So if it's over 550, we can trigger. If not, it's not going to trigger. It's false. And then let's add the trigger. IT velocity. By the way, if you go back into the trigger, class settings, blueprint display name, that should be it. We'll call it velocity threshold. And there we go. Now it's called velocity threshold in the list. So let's see. So you can see up here. Let's do this. I'm hitting space. You won't jump. So hold down space, I'll move, and then he jumps at that point. Alright, so that first trigger was easy. Let's do something a little more complicated. So we're going to be doing a trigger with a built-in cooldown for the input. But first I want to demonstrate what I've got. I'm going to remove velocity for a second. So on jump, we have pulse, which is kind of similar. You can make it fire in intervals. So I'll set it to 2 seconds. And so you see every 2 seconds it fires, which is kind of like a cooldown. But see, if I wait, I'm waiting 2 seconds without holding it. And the cooldown is still built into it. So it's 2 seconds of holding it, not 2 seconds of in-game time. And the other thing you'll notice, it's only firing once. Okay, I'll change that now to what I have here. Cooldown on trigger, which is similar to pulse, but it considers game runtime rather than hold time. Okay, I'm going to let go on trigger. I've waited 2 seconds. And again. So you see, I don't have to hold it. But it also only fires once. This is the simple version. Now we have cooldown on release. So see, I keep jumping. It keeps triggering. But if I let go... So on release, I have to wait 2 seconds. Okay, so let's go through how to make these. So first, we'll do the same thing. We're going to start with the simple one. So just do the standard trigger. Okay, let's open that. First, let's make the variables you'll need, which is the actual cooldown. We'll set that to 2 seconds. Another float. Cooldown begin time, which I'll put in description internal, so we're not supposed to modify that. Okay, and then there's a function current time. You can drag out and create a return node. In here we just want get accurate real time. And we're going to add the seconds to the partial seconds, and then plug that into the return value. So this is the application runtime, which is the only measurement of time we have. Okay, and then we just override update state and override get trigger type as well. In get trigger type, we can delete that, drag this out, promote to variable, call it trigger type. So trigger type is necessary because normally it's explicit, meaning input may trigger if any explicit trigger is triggered, which means it won't consider other triggers. Implicit may trigger only if all implicit triggers are triggered. That's what I want. And the blocker is basically inverted. Inverted trigger that will block all other triggers if it's triggered. So we can set that in the input mapping context. We can leave it for now here. So in update state, this is the main function of the trigger. We can delete the parent function. Drag out a branch. And we can get our current time. That should be pure, so just click that. And we're going to subtract the output there with cooldown. And then pull out greater than or equal to cooldown begin time. So if current time minus cooldown is later than when cooldown began, then success, if that makes sense. And so if it's true, we set cooldown begin time. So this is the value. It's just going to be current time at the time. But this will only ever be set again if the trigger succeeds, thus creating a cooldown on triggered. And if it's false, we just return ongoing. Okay, so that's not too bad. Oh, we gotta set that to triggered over here after the true. And in class settings, I'm going to set this to demo cooldown on trigger. So always make sure it works. There's demo cooldown on trigger. Cooldown is 2. This is internal. Okay. Looks like it works. Now let's do the hard part. So I'm going to select my demo cooldown on trigger, Control D to duplicate, and I'm just going to change it from on trigger to on release. And let's do the same thing. So there's one more function we need. It's going to be is continuous. And real quick, before I forget, in class settings, we need to change it from an input trigger to an input trigger timed base. And that gives us this variable, held duration. So is continuous. That's going to go right here. So delta time is the time since the previous frame. So by adding that value to held duration each frame, we end up with total time held. And we're going to need that. So drag out here, set held duration. And all we're doing is we're adding delta time to held duration, which obviously will start out as 0, but will slowly add up with the passage of time. So that gives us how long we're holding it down. So let's separate, let's give us some space here. So instead of going straight to this branch, we need to put a sequence in here. And this branch is actually second. And on the first part of the sequence, we have another branch, which is where is continuous will come in. Set that to pure as well. And let's go in is continuous. So the input variable here is going to be a float, and it's going to be delta time. And let's just set up the output as well. Output is going to be just result. It's just going to be a Boolean. So let's grab our current time. Minus. And now we need a new variable. So let's do that. And I'll call it last runtime update. This will be set at the end of each execution of the trigger, or evaluation of the trigger. So even if it fails, last runtime update has to be called. Input triggers contain strictly functions, so there will be no use of delays or on-released events. All we have to measure time is variables and application runtime. The good thing is input triggers seem to be persistent in the game. That is, once you release your input, the trigger doesn't get, quote, destroyed, as in losing its stored variables. So last runtime update will be remembered. So delta time is the engine's record of time in seconds since the previous frame. With our own variables, we can check the difference between this and the last frame is equal to delta time with some deviance. So let's put that in there, the nearly equal. So if delta time is nearly equal, because it won't give you an exact equal, there's always going to be a little tolerance for whatever reason. So the error tolerance will just be delta time again. So if it is nearly equal, we consider this frame as part of a continuous hold event. And keep in mind the key being pressed is required to even get here, so we don't even need to think about if the key is pressed or not. In fact, that's part of the problem. This will never fire when the key is released, because it would be so much easier to just have a function or event execute once the key is lifted, but that doesn't happen with a trigger. So this is the alternative. Okay, so we have our nearly equal. Plug that where they go. So we don't actually care if it's continuous, we care if it's not continuous, where you then set cooldown begin time. Since input triggers can't use anything like an on-released event, we have to treat every tick as if it could be the last one in the key press event. I use cooldown begin time being set, so non-zero, as a signal that we have an active cooldown in effect, which will only be considered on a new key press. Like, this is false. And because this is the first key press since release, we will still have last runtime update, which we can then assign to our cooldown begin time. So the condition is cooldown begin time is equal to 0. So if it's 0, we will set this in a second, but it will be last runtime update, which is the saved total runtime from the last update, which, since this is a new key press, makes it the runtime of key release. And finally, for this part, set held duration to 0. So let's move on to here. This remains the same. However, in this case, we set this to 0. Okay, so in hindsight, this message I'm pasting here is kind of misleading. This is not set to 0 to tell the next tick. It's to tell the next key down event So the next time you have released and then pressed it again, which will tell the select node to use last runtime update instead. Okay, so we still trigger here, and after cooldown begin time, this is where we set last runtime update. Of course, that will be current time, which will then be carried over to the next frame where it will no longer be current time. So basically going back up here, cooldown begin time. If it's 0, it will use this variable from the last frame. And this false is just a failure. So we also have to set the last runtime update. And that should do it. If you're using the first velocity trigger too, remember to add trigger type as well and get trigger type and set it to implicit. Nope, not yet. So go into mapping context, and it's going to be demo trigger on... Oh, I said trigger. Whatever. It's supposed to be demo cooldown. Okay, so it's continuously triggering. There's something wrong. Okay, I figured it out. So in my reference, I have this select node, but look at this. The select float and the select node are inverted. So cooldown begin time should go into false. All right. Well, there you go. Hopefully you learned something. Hopefully I made sense. But yeah, anyway, if this was helpful, like, subscribe, leave a comment, and I'll see you in the next video.